Okay, so MapReduce is this programming paradigm invented by Google, and the reason they invented it is because they realized that programming kind of highly distributed computation is hard because you have to deal with a lot of communication issues between servers, and so they wanted to kind of abstract that out so that you could just write, a couple simple functions, and then the system itself would handle moving your code around to all the machines that have the data.
Okay.
And then you would process the data on the machines in parallel. So you can literally run MapReduce or Hadoop on hundreds of machines at the same time, doing basically the same computation on a whole bunch of data. So Hadoop. So unfortunately, Google has not has not open sourced their implementation of MapReduce. And so what Hadoop is, they basically took the paper that Google wrote, it was like an academic paper, and they took that and they said, okay, well, we're going to make an open source version of MapReduce. And that's what Hadoop is.
Okay.
So Hadoop is a system that allows you to write these, simple two simple functions, map and reduce, are the two functions. And then it takes care of kind of distributing your computation among a cluster of servers. So the reason you would use Hadoop is if you have this massive data set that a single machine can't really handle very well. And yeah. So to answer your question, Hadoop has what's called the Hadoop file system, and the Hadoop file system stores data across the Hadoop cluster. And it stores it redundantly, so if any kind of child node in the Hadoop cluster fails, it'll still have another copy of the data somewhere else. And same thing with the computation. If you have a cluster of 1,000 servers, every week, one might fail. So you're like, okay, well, I need the system to kind of deal with that without me having to go and manually restart stuff. And so that's how Hadoop operates. So there is this thing called HBase, which I'm not really going to talk about, but since you brought it up, HBase is sort of it's similar to Cassandra. It's similar to other NoSQL databases.
Okay, right.
HBase is kind of like a NoSQL database that uses the Hadoop file system. So you can run HBase on Hadoop and get a standard NoSQL type interface. Now Amazon actually has a NoSQL. Well, so there was SimpleDB, which you mentioned.
SimpleDB, and they just came out with Dyn.
Yeah. So DynamoDB, which I'm going to talk a little bit about, is their kind of NoSQL database as a service. So it's not something they have to download. It's something that they manage on their hardware. They run hardware with solid-state drives to make it really fast. And they also manage kind of data partitioning. So they kind of spread your data across as many machines as it needs to be spread across, either for storage requirements or for throughput requirements. So how many writes per second you want to do, how many reads per second you want to do. And you can literally go in their interface and dial up that number whenever you want. So you say okay, well, tomorrow I'm going to be in a Super Bowl ad, I need 10,000 writes per second. And you can just go in there and it'll take, maybe a few minutes or an hour or however long to get to that ability. So it kind of moves your data around and says, okay, well, now we can accept your large request size. So I talked about Hadoop, talked a little bit about MapReduce. So Amazon Elastic MapReduce, I don't know why they don't show you what page you're on, but this is, by the way, this is the Amazon or AWS Management Console. This is the Elastic MapReduce page, but you can select any number of other services here. So if I wanted to see like my tables in DynamoDB, I can just switch to that. This is a new nav bar. There was an old one. I don't know. Maybe they don't let you switch back to it anymore. But anyway, I should really just put this in here. Let's see. We'll put DynamoDB. Where's Elastic MapReduce? Elastic MapReduce up there. So these are just like little shortcuts. So Elastic MapReduce. So Hadoop is this open source tool. Primarily, it's actually developed by Yahoo. Yahoo has most of the contributions to Hadoop, the open source project. And you can run Hadoop on EC2 directly if you want. You can just launch up some EC2 instances and install the software on there, and install set up a cluster and like configure it so that they all talk to each other and stuff. But then Amazon came out with this new service called Elastic MapReduce, and basically this service configures your cluster for you. So you tell it like, okay, I want one master node and then like 3 like processing nodes or something, and it will configure Hadoop for you so that it knows like who to talk to who and stuff. And you can also, I believe, you can increase or decrease like the amount of compute resources in there, and it'll like know what to do. So from my understanding, although I haven't actually set up Hadoop like directly on EC2, from my understanding, this is a hell of a lot easier to do. So and it was really easy to do this, and I can show you.
Are these jobs that you've actually already run?
Yeah.
So you have enough data where you're actually taking an hour to do your batching already, even though you're not.
So that's one interesting thing about Hadoop, is that since it's set up to deal with a large data set, because it's designed for large data sets, it kind of, I feel like it just does more than it needs to, even if it's dealing with a small data set. So like, yeah, if you're dealing with a small data set, like, and you want it to be fast, like, don't use Hadoop. Because yeah, like, it should not take an hour to do this. Like, literally, with the amount of data I have in MySQL, it takes less than a minute. So, like, okay, well, there's something wrong going on here. But the theory is that once you do have a lot of data, it won't. It's not going to scale linearly. Like, twice the amount of data is not going to take 2 hours, for example. There's kind of like a certain.
It's spinning up resources to handle this. And
yeah, I think it's just spinning up a bunch of like Java processes or something. I don't know what it's doing really. But I know there's a lot of companies that use Hadoop to deal with big data, so I'm not one to argue with them right now. Okay, so if you just wanted to play with this right away, you could go and create what's called a job flow. This is an Amazon term, this job flow thing. Choose the version of Hadoop you want. I guess they have this thing called MapR. I haven't used MapR, but maybe you'd be interested in that. So let's run my own application here. I'm going to run a Hive program. So there's this thing. So Hadoop, there's different ways you can use Hadoop. So there's Hive, there's Pig, there's this thing called streaming, there's HBase, and there's a custom jar. So back in the day, before they had all these other fancy things, the only thing you could do, I believe, was a custom jar. So you would write some Java code, and it would run your Java code. But now they have these other better things. So streaming allows you to write MapReduce programs in other languages besides Java. So you can run it. You can write it, using Node.js, or you can write it using Python or Ruby, or whatever you can get running on a Linux box, like at the command line. You can just do it. So if you want to write your program in C, assembly code, whatever, as long as you get it running at the command line. It basically just takes input from standard in and output goes to standard out. I'm not going to really talk about pig. Pig and Hive are sort of similar from what I understand, although I haven't done a whole lot of thinking. From what I understand, what people talking about on the internet is that Hive is kind of easier for people to grasp. So Hive...
Is that closer to SQL?
Yeah, so Hive basically implements SQL on top of MapReduce. So it takes SQL queries and it turns them into MapReduce jobs for you. So let's say you have a bunch of data in Hadoop, and you want to say, okay, well, I want to filter it, by this column in my CSV. Let's say you have 10,000 CSVs, with a gig of data in it each or something. Like, okay, I want to only get this subsection. You can use a really simple query in Hive. You can just do select star from table name where this equals that or whatever. So we're going to do Hive. So that's what I'm using. I'm using Hive. Start an interactive session. So you can either set up a Hive script, and you can put your Hive script in S3, and then it'll pull from S3 with some arguments, like if you want your input data, or your output data.
So is the script just a single file, text file?
Yeah, it's just like a series of Hive commands, which are like SQL. It's called HiveQL, so the Hive query language. It's very similar to SQL, but there are some differences. And actually, well, I'll tell you about that later. So for now, we're going to start an interactive Hive session. You can select, so there's 3 types of instances in your Hive cluster. You have your master instance, which is just going to be one instance that kind of controls the whole thing. It's kind of like the person in charge of the whole fleet. Core instance groups, or core instances, they store the data and also run processing. And then task instance groups, they don't store data, but they do run computation. So the task instances have to pull data from the core instances. I'm not sure why this is separated out.
Is one cheaper than the other, you think?
No. I mean, you can select what kind of sizes you want each of these to be. So depending on your use case, you might want a different size.
And the cost is only in the EC2 instances that launches, like this overlay on top of it, there's no additional cost?
Actually, I think there is a small additional cost. Let me look at that. EMR pricing. But it's pretty negligible. Okay, so you see, here's the EC2 price, and then, wait, is that? Oh yeah, the Elastic MapReduce price is on top of that. So here it's 8 cents an hour versus 8 cents plus 1.5 cents. So it's like,
those are additive when you run it?
Yeah, so you pay for your EC2 usage, and then you pay for this on top of it. But 1.5 cents per hour versus 0.8.
Can you use reserved instances? Do you know?
I believe so.
Okay.
Are they on this page?
Oh yeah, there is at the bottom.
Yeah. Oops.
And maybe if you have extra reservations, it probably just uses that.
Yeah. So these Elastic MapReduce, the service, does actually launch real EC2 instances. And you can go into the EC2 instances page and see all your instances. So you can actually, SSH into each one individually if you feel like it. If something goes wrong. What I've been doing for testing purposes is I've just been setting this to 0 and just having one EC2 instance, which is the master. You have a key pair. If you know anything about EC2, you know what this is. It's basically the way you log in. public-private key. There's bootstrap actions, which you don't need. And then, yeah, so you just create this, and then it would take a few minutes to start, but I've actually already started one a few minutes ago, so hopefully it's ready. So this is the one I just started a few minutes ago. It was 25 minutes ago, really. All right, so I have this master public DNS name here. So this is the host name of the master instance that you can SSH to. So I've SSH to it over here. So I just did SSH -I and then the location of my private key in my key pair. Username is a Hadoop, and then the server is that server that I just copy and pasted in.
This is one that you set up as an interactive session as well.
Yep. So this is an interactive session. So you'll notice. So when when Elastic MapReduce starts, it sets up Hadoop for you, but it does not set up Hive for you unless you select that you want to run a Hive program or a Hive interactive instance. And what that actually did is it put this step in here. So these steps, these could be like pieces of your job. So you could like string multiple jobs together, and you can actually add to this list interactively. So if you want to, I don't think you can do it in the web console, but you could do it in the API. So you can add more stuff to an ongoing session or an ongoing Hadoop cluster. So the first thing it did here, you'll notice it ran the script runner.jar with some arguments, Hive script, and then there's a command here that says install Hive. So basically what this did is it installed Hive, and it says it's completed. So Hive is running, and so I went over here and I typed Hive in the command line, and then now I'm in the Hive console. So I can just start typing SQL commands, or really Hive QL commands. Of course, there's documentation for this.
So when you start doing querying, is it actually pulling it from, like, where's your persistent data store? That's not Hadoop, right?
So you have a choice of persistent data stores. You can either use Hadoop's data store, which is the Hadoop file system.
That's just like a key value store.
It's more like a file system. So it's got like directories, and you can put files in there. But the file format is sort of like CSV or like tab separated values. So in the Hadoop file system, you can put whatever kind of file you want. But if you want to use Hive on top of it, it has to be a little bit more structured. So it has to be either CSV or tab separated.
Right. So when you're actually in your application, when you log in, who's clicking on ads, who's using what app, how are you logged? Is that being logged to MySQL, and then do you export that how?
So the way that we do it, you don't have to do it this way, but the way that we do it is we, when we get data from these devices, when the devices send it to our server, it actually gets stored in DynamoDB. And Amazon Elastic MapReduce is set up natively to read directly from DynamoDB and also S3. So you can push and pull data between DynamoDB and S3.
Are the devices running to that? Or are you running to like a web service and the web service is communicating?
Yeah, there's a web service. I'm actually running the web service on Heroku,
Okay.
which is actually, I believe, in the same AWS region as like the DynamoDB instance I'm using.
Do you know if it can work with SimpleDB?
If what can work with SimpleDB?
Well, you said it can access DynamoDB
Yeah.
or S3.
Yep.
simple DB as well?
Oh, no, not SimpleDB.
Okay.
Because SimpleDB has a limit, like on the size of your database. I think
Right.
each database is like 10 gigs.
Something, yeah.
It doesn't really make sense to use SimpleDB in sort of like a big data context.
Okay. Right.
I think that's why they didn't bother to implement it. Of course, you could implement it yourself. I mean, you can run whatever program you want on these EC2 instances. And actually, this thing right here, this script runner jar, you can run whatever command line program you want, and it pulls this from S3. So this Hive script, I forget what language it's written in, but I think it's just like Ruby or something. Here, let me just show you how simple this is. So I just downloaded the script that it ran to install Hive. Oops. Shit. No. Where's my downloads?
How close are you guys to launching or have you?
We're launched, so you can download the widget. Developers can integrate, but there's no apps yet. Like, there's no developers who have integrated with us yet. So we're trying to work with some developers to get it integrated. So this Hive script that it pulled from S3 is literally a Ruby script that installs Hive for you. Like, that's what it does. But you can write your own scripts to run whatever sort of command line thing you want. It's just like a Linux.
Do you use expansions like on the shell, the Hive shell, or is there an API built around the Hive shell? Or the Hive?
So you can run command line scripts, and then there's also you can pump HiveQL queries into the Hive shell. So yeah, you can run Hive queries through this mechanism
So you
as well.
expect in there, is there like a REST API or anything like that?
For Hive, you mean?
Yeah, like if I were to write a Python script,
Mhm.
would I have is there a Python Hive library that I would have to import, or do I actually spawn a shell and communicate with that, or? I guess
I think you'd either have to use SSH, like
Okay.
you'd have to get it to SSH to the server, or you can just put your Hive queries in a file in S3 and then tell the Elastic MapReduce to run that.
Okay, so I wouldn't put my Python script on the actual.
You
server.
could if you wanted to. You can just download the Python script from S3 and then run it as a step.
But this is the interface to Hive.
This is like the user interface to Hive. If you wanted to run interactive queries, you can run queries in batch. Like I said, you can just take a file of a bunch of
Right.
HiveQL commands and just put it in there.
I don't know if you can get to this or not, but what kind of queries are you actually running?
I'll show
What
you.
would be the equivalent SQL?
Let me open up my. This is one of those things that's like not like super top secret, but don't like go posting it on the internet. Let's see, where's my queries? Okay, so here's where I can tell you about my little open source project I wrote. So this queries.sql, these queries are actually MySQL queries. So I can run these queries in MySQL. So what I did is I wrote a converter between MySQL queries and Hive queries. It's pretty limited. Like, it only works for like these queries, and if you try to like write other queries, it might fail. Depending on how complicated they are or what features of MySQL or Hive you're trying to use. So after I run the converter, it generates a different file. Where's my Hive queries? Here it is. Okay, so these are Hive queries. So they're similar. There's only a couple differences. One is the insert statement here. This says insert overwrite table, and then the table name. The other difference, which is kind of random, is just the time format. The way that it accepts this time format parameter is different. So I think those are the only.
So it's
real
like inserting
differences.
like temp tables. Is that kind of the format? So like the insert overwrite table means like inserting into the special table the results of this query.
Yeah. So the way this is working is it's taking data from one table, it's running the MapReduce job on it, and then it's putting it into another table.
Then what are you doing with that table?
So after I run all these queries, I take basically the summary data, and I'm moving it into MySQL. So I'm kind of doing all this processing on this big data, and then I have summary data that I can kind of stick in MySQL for reporting. And that the size of the data is a lot less. And the way I'm doing that, the way I'm converting from Hive tables into MySQL tables, is I'm using this open source project called Scoop. I think that's how you pronounce it. Scoop. What Scoop does is it transfers data between the Hadoop file system and a relational database. So I think it works for like Oracle and MySQL and Microsoft SQL. I think anything that has a JDBC driver you can do. So yeah, that's how it works. So I have a web service that is taking data from the devices. It's sticking the data into DynamoDB. I have a cron job that once a day kicks off an hour-long Hadoop process, and that crunches on the data and then exports it to my MySQL database. And then we have a front-end web interface that developers can log into to see that summary data, or to see how much money they made during the time period.
So that hour long that you're running the good processes, do you like spin up the instances and then shut them down, or are they always running?
Yeah, so every time I'm only running it for like 1 hour a day instead of 24 hours a day. Yeah.
And does it shut down automatically when you're done?
So what you can set up, well, ask MapReduce to do, is you can set it up in two ways. You can either have it, what I did, this is interactive mode, and after it's done with the steps, it'll stay alive. You can also set it up so that when it's done with these steps, it'll stop. It'll terminate the entire cluster.
So is that showing that like it's taking around 50 minutes overall? So like 45 is starting up, and then only a minute or a couple minutes from 1841 to 1843 that it actually ran your step.
I will show you. Here's my actual steps. So I have like 10 steps here, and you can see the start and end dates here, which has a time. So let's see. It takes about a minute to set up Hadoop debugging. Takes a minute to set up Hive. Takes a minute to install Scoop. It takes 3 minutes to import some data from a MySQL table into Hive, or into Hadoop rather. Apparently it takes 0 minutes to set up the Hive table schema. I mean, that's probably like 30 seconds or something. Running the Hive queries takes about 6 minutes. Or sorry, the Hive import queries. These, I believe the Hive import queries take data from DynamoDB and put them into the Hadoop file system.
Okay, so that's where you're loading your. And you've got your Hive running now. You're loading all the data into it, basically. that.
Yeah. So you could run Hive queries directly on data in DynamoDB, but because DynamoDB has a limit, like because the way that DynamoDB charges for read and writes, it's better if you just read it once into Hadoop and then process the data there and then move on. So I have it in separate steps, but you could do it in the same step if you wanted. I don't know, for some reason, if you want to do that. So there's 6 minutes there. This is what takes a long time. So this is like 25 minutes to run the actual queries. So each query might take a few minutes, and I have like 15 of them or something. So.
And then the scoop export is transferring it to your MySQL summary.
Yep. So that takes like 7 minutes, which it really shouldn't take that long, but it's actually running MapReduce jobs. That's why it's taking so long.
Did you say how many rows you have? I guess I don't know if rows is the right for
Rows, not that many. So like on the order of like 100. It's
Really?
Yeah, it's tiny. So I'm assuming all this time is from kind of the setup process to get like, a MapReduce job going. And then I think it like waits 10 seconds every time, like it checks to see if like the data is ready, and then like if it's not, then it like goes and does something else, and then checks again. So it's not, like I said, it's not very efficient for small amounts of data. But the theory is that once you get a large amount in there.
So if you were to do the run Hive queries again, how long do you think that would take? Like the same query, once it's all set up.
Well, it'd take the same amount of time it took the first time. What, 25 minutes here?
I guess I don't understand. Why would you use this versus a single non-distributed database?
Like I said, if you have more data than can fit or can be processed in a single machine.
Okay, so you wouldn't use this. I mean, obviously you wouldn't use it for a small data set, but you wouldn't use it for a large data set that fits on a single server.
I mean, if you can store and process the data on a single server, and like the time it takes you to process is acceptable to you, then just go for that.
So you're just planning that you get hundreds of millions, maybe billions of rows. The time you see is going to still be similar to what you're seeing now.
I think so. And I've done some tests with a lot of rows, and that seems to be the case. It doesn't take much more time.
So what kind of like queries are you running? Is it? I mean, are you just doing like grouping the number of uses of an app by a particular developer and like showing people that?
Yeah, I mean, I'm doing. Let's see.
Basically, just reporting on usage, right?
Yeah, so I'm doing a bunch of group bys, doing some table joins here, some filtering. Yeah, some summarization, counting, count distinct here, substring. Well, it's a substring.
Have you ever just dumped some like dummy data into it, like hundreds of millions of rows, just to see how the performance of this queries versus direct SQL queries?
Yeah, so I've dumped enough data into. I believe I've dumped enough data into Hive that it took less time for Hive to process than MySQL.
Do you remember like where that is? I'm
No,
just curious where the sweet spot is, where it makes sense. Like maybe I should break out the loop for this or something.
I'm not sure.
So, wait a minute, I'm confused for a second. So the data you've got, you're storing in DynamoDB or MySQL?
So it starts in DynamoDB.
What is a Hadoop it's not a Hadoop file system, right?
It temporarily is.
Well, I know that, yeah, but I mean, where's your real persistent source?
My real persistent source is DynamoDB.
Okay.
So it goes from DynamoDB into Hadoop and then out to MySQL.
Okay.
The summary data.
Okay, I was getting confused. Now, if you had a really large data set, you know, it's say in DynamoDB with it's lots and lots of rows, but the rows are all, I mean, there's not much complexity to it. The rows are all similar kinds of fields. If you had like user interface where folks were going to search and do stuff for that, you would still want to do that through DynamoDB, or would you have Hadoop?
It depends.
Hadoop's kind of more, at least the way you're using it, it looks like, well, I'm getting confused between we're doing with Hadoop and what we're doing at Hive. It's very batch, kind of, let's go get a snapshot and play with this. Okay.
So I'm actually, the way I'm doing this is not optimal right now, but since it's only running for an hour, I don't really care.
How much is this costing on a monthly basis?
So,
In resources?
what is it like? If I'm doing an hour of EC2 a day, you know, that's less than 10 cents. So 10 cents times 30 days.
Plus your 0.015 cents a day, right?
Well, that's like included because it
Well,
was
that's
like
included. That's 9.5 cents.
it's 9.5, yeah.
Okay.
And then how much is DynamoDB costing? Again, that's not cheap.
Yeah, DynamoDB is a little funky. And early on, I had some issues with this read and write throughput. Because if you bump up this read and write throughput too high, it'll get expensive. So I think 5 reads and 5 writes is the minimum. So that's kind of why you see a bunch of 5s. And then for some reason, you can also set it for 3. So this is
Scale.
5 writes per second.
Okay.
But it's actually a little more complicated than that because it's like 5 writes of 1 kilobyte. So if you have a write that's more than 1 kilobyte, then it charges you like for 2 or 3 units.
Did you ever have any issues with latency? So I've played around with it a little bit in for some sessions, and it just wasn't fast enough. Which kind of blew my mind, but I ended up going over to Elasticache because it just wasn't working out so well.
So I don't know. I found DynamoDB to be really fast. It might have been because you're running into the limit of your table. Like you might not have this number high enough.
I mean, I guess it's possible, but I mean, I was just in a test environment. For me, fucking around. I guess it's possible.
I mean, SSDs are slower than RAM, so that might have been what you were experiencing.
But I'm saying it was taking like 10 seconds for page load, and then eventually it was timing out. And
No, DynamoDB shouldn't do that. If you have these numbers set high enough, it shouldn't do that.
Maybe I would do something wrong.
You can actually look. So there's statistics about like how many what they call throughput exceptions. A throughput exception is when you try to make a request and it ran out of units of read-or-write capacity. So you can actually go into CloudWatch and see.
Frozen HTTP 400 something, right? It doesn't actually queue them, right?
Right. So most DynamoDB libraries, in fact, maybe all of them, have automatic retries put in. So when you do a write to DynamoDB, typically what will happen is your client library will try once, fail, and then try again, fail, try again, fail, until it's able to connect up to like a certain amount of time, like maybe a few seconds. And then if it fails after a few seconds, then it'll punt back with an exception and say like, hey, you can't write. So maybe that's the slowness. I don't know. Try it. I mean, I can help you out if you want. See if I can debug it. So here's some metrics. So for example, here we go, throttled requests. Apparently I had one that's average. I think this is... Okay, so in a couple minutes here I had 11 throttled requests, and then the next one I had 27 throttled requests, for example. You can see the kind of latency on these things. Let's see if I can find... It should be... Okay, so 4 milliseconds. I'm assuming that's measuring like within DynamoDB. It's not like connection between wherever your app is and DynamoDB. So it'd probably be like more like 10 milliseconds or 20 milliseconds.
Yeah, because all the interfaces with this is HTTP.
Yeah. Yep. All right. So explain MapReduce, Hadoop, EMR, AWS Management Console.
The only interface to the DynamoDB is HTTP.
Right.
Yeah.
Which, I'm wondering how much to set up the connection, tear it down. I mean, it's going to be a lot of work. If you look at like a Elasticache, which is an MCAG-B, I mean, it actually runs its own TCP connection. I'm just curious how much that would actually affect performance.
You can do batch writes. Yeah, you can do batch reads and writes. So you can write like 25 items at a time and receive 25 items at a time. Or actually, I think you can receive more than that. But you can only write 25 at a time. All right. Everything you've seen in the management console you can do with the API. Any questions or things you want me to cover more?
What's been some biggest gotchas working with it?
The first big gotcha, I guess it doesn't relate directly to Hadoop, but with DynamoDB, the pricing and the read and write throughput. So you basically pay per hour for the read and write throughput whether or not you use it. So it's like, yeah. So it's like,
Why would you just set a high number and get service? But yeah,
it's sort of like starting a server and then not making requests to it, or like setting up a database and not using it. It's the same sort of thing. So with DynamoDB, you say, okay, well I want this table and I want to do this many writes, but if you don't do that many writes, it's still going to charge you for them.
You could script around the API and monitor throughput and bump this up, on demand, but they're not going to do that for you. And
Turn it off except for when you're running your job.
So there's a
yeah.
sort of says a fair amount of sysadmin monitoring to try to fine tune to optimize.
There's a cooldown period though. Like I think they knew that people were going to do that. So you can increase it at a certain time, but then like you got like a wait a day or something like that if you can drop the throughput down.
Yeah. So basically,
It's still not a set and forget.
Right.
I mean, you can set and forget as long as you're okay with the pricing. I mean, it's actually like spinning up server resources for you. It's like ready for the army to approach. So here it is. So
The DynamoDB is not included in the free development tier, is it?
what does it say?
Free tier.
It's part of the free tier.
Oh, okay.
You get 100 megabytes of storage,
5 and 10.
5 writes, and 10 reads. So that basically gets you like one table to test out with twice as many reads as is the minimum.
So, since it's all EC2 internal, it doesn't matter how far you parallelize, the data sharing between is all free, right? Within the EC2.
Data transfer between EC2 instances is free. Yeah.
So, okay. And that would include like any sort of parallelization across Hadoop.
Yeah.
Okay.
So if you set up a Hadoop cluster, it's all going to be in the same region within Amazon's network. So they're not going to charge you for that data.
Okay. Can you replicate across multiple zones?
Yeah.
Well, the way that Hadoop is set up, it does replicate like multiple servers. I actually don't know if you can do it across zones.
Very few of the services do. I wouldn't surprise me.
You mean like availability zones?
Yeah.
What does it say? Availability zone. Yeah, it looks like each Hadoop cluster is only in one availability zone.
That makes sense.
So
I think we're going to about data transfer between the two. Yeah, that's included. They don't charge you between data transfer between AZs, but between regions of data.
all right, well, it's 5 minutes left. I'm going to stop this. This is shutting down. What else? Oh, I can show you guys my little converter I made between MySQL and Hive. So, I basically wrote these queries with Hive in mind, but I wanted to test them first in MySQL because the syntaxes are so similar that if I made a mistake here, like if I made a programming error, I didn't have to wait for like Hive to like run a minute or two before I got the results. So I actually test my queries in MySQL first, and then kind of just double check that they work in Hive after it's all set. Just to reduce development time, and I don't have to like spin up a Hive instance just to kind of develop.
Is this project the first project you've worked with Hadoop and Hive?
Yeah.
So describe what the learning curve was.
Setting up a Elastic MapReduce cluster was really easy. I kind of described how it was. It did take a little bit of time to like kind of learn all the intricacies of like what's available in the Hadoop environment, but it was just a matter of like, okay, well, what tools do you use to do what? And so it's just a bunch of kind of Google searching. So it wasn't too bad. Setting up Scoop was kind of a pain in the ass, but fortunately for you guys, if you want to do this, Scoop. Fortunately for you guys, I wrote a blog article about how to do it because I couldn't find one. So I think you can just Google it. I think I'm the first result. So what else? Hive was just SQL, so I kind of took my knowledge of SQL that I had previously and just kind of applied it. Like I said, there was a few differences, but not too bad. As far as like setting up tables in Hive, which I guess I didn't show you how to do, but in the Amazon EMR documentation, there's like examples, and so you can just basically copy and paste those and change some stuff for setting up your tables.
So once it all comes up and you hit steady state, what do you what do you really have? What are you going to do with it at that point? What kind of queries can you do? It takes half an hour to get everything imported and running and the queries set up. Do you just have a data table at that point? Do you have something that you can easily insert new data into?
So if you want to keep your Hadoop cluster running, and you want to use something like, you want to like add data as you go, I'd probably recommend using either HBase or something like it. I think HBase is what they use at Facebook.
So the real purpose of this is not. I keep thinking of it like MySQL or something, Mongo or something like that, where it's always up and I can go whenever I feel like and just say, oh, what's going on with my data?
You can leave these up. There's nothing stopping you.
That's probably how most people use it, leaving it up, right?
Really?
I don't know.
But you can't do like interactive queries. It's gotta you gotta queue it and wait for the response.
Right. It seems like it's more useful to I'm gathering data over here once a week. I'm going to take these 150 million rows and process them into a single report. Is that kind of what?
OLAP is what they call it, right?
You can do whatever you want, really.
I'm trying to figure out the use case, really. But, I'm sure you can, but
that's how he's using it. What you just said, yeah.
Okay.
Exactly what they're doing.
So Hadoop is basically it's a batch processing system. So it's not something that you would open up a web application and use Hadoop to like power it.
That's kind of what, yeah, that's what I do so often. That's kind of what my head's, yeah.
And because it takes so long to run each Hive query,
Right.
you don't want somebody sitting there waiting for it typically, unless maybe you're at Facebook and you're like, okay, well, I'm Mark Zuckerberg and I want to know like how many likes I got today across all my users,
Sure.
and I didn't already set up that query to run, so I need to like just manually do it.
Okay. Or you're processing
And then
genomes or something.
yeah,
Okay.
and that would take like an hour or 2 hours or whatever.
Right.
If you had like 10, 20 servers, you could probably process that all in
Got
a
it.
couple
Okay.
hours. But Hadoop is not something that you want to set up for your users typically. Like it's something you would use internally for batch processing of data. And like the way I'm using it, I'm only running it for 1 hour a day. And ideally it'd be less than that, but the setup takes so long. But fortunately, like the way EC2 charges is per hour, so as long as I can use it for 1 minute or an hour, and it would charge me the same for the EC2 time. So yeah, it's primarily for batch processing of like large data sets.
Okay. I'm trying to fit it into my usual use case. That makes a lot of sense. Thank you.
Yeah.
And you're using it basically to give you a report on your mass data set of just a summary.
Yeah.
Is there other typical uses of it other than that?
I mean, the way Google uses MapReduce is to kind of, it's going to sound funny, but they use it to, download the internet, download all web pages everywhere, and then, we want to index the internet, so we want to find out which pages have the word "the" on it, or some, probably some more complicated word, but, and then we create these kind of data structures where when somebody actually goes to google.com and types in a query, it doesn't actually have to search everything. It just searches like this one little data structure that has like the exact answer for their query.
That's how it does a quick
Yeah,
search for you.
it's like really fast because Hadoop, is primarily for building these indexes. So taking kind of this huge data set and putting an index on it so that future queries are faster. There literally is no indexes in Hive. Like you use Hive to build indexes. I mean, maybe with the latest version of Hive, there's like some indexing, but in the past, it's been used, to kind of create these indexes as opposed to like, have indexes on your tables and then just manually like query them over and over. You usually only want to run these queries like once and then move the data somewhere else, and then you can like, put it in a spreadsheet or in MySQL or Mongo or some other data store that you kind of run live queries on.
And the output of this is the CSV you were talking about?
Yeah.
Okay.
I believe the New York Times has actually used Hadoop to OCR a bunch of text images and then convert them to PDFs. So, if I remember recalling correctly, I think it was Hadoop.
Yeah. So this is kind of why I was trying to make a distinction between Hive and Hadoop. Hive is kind of like this thing you have to have CSVs for, and you have to kind of have structured data. It's more relational. So you have columns, you have rows. Whereas Hadoop, you can kind of put whatever kind of data in there you want, like videos or audio, or just sections, chunks of HTML, and then you can run whatever process you want. If you're not using Hive, you can run, you can write MapReduce queries directly. But MapReduce queries are more complicated than SQL, typically.
So if you're putting videos or audio, that kind of data into Hadoop,
It's used for
you use different
transcription.
process.
Oh, that's what you're talking to him.
Yeah, you use different process. You use other than Hive. You use one of those other processes in that drop-down menu.
Yeah.
Depends on what kind of data you're giving.
So you could use streaming, or you could directly write, what's this called, custom jar, So a jar. Are you familiar with jars?
But in that case, you'd likely want to have the Hadoop would be persistent.
Well, for as long as you wanted to run your job. So like, if you were a company like YouTube, then maybe you would constantly run a Hadoop job.
Yeah.
You know, like data would just go into it. And
I was saying,
come
yeah,
out
like
the other side.
a situation like that where folks are uploading videos or other kinds of files as kind of a central shared storage.
So
you'd probably use the Hadoop would be persistent, right?
yeah.
Okay.
Hadoop is not. It's not very good at being a database, honestly. That's kind of why they built HBase, kind of on top of Hadoop. I haven't personally used HBase. I haven't had a good reason to yet. Right now we're using DynamoDB because we don't have to worry about like keeping the software running and managing a Hadoop cluster and all that stuff. Kind of.
HBase is the key value store. It's very similar to DynamoDB. It's like a Cassandra or something.
Yeah, as I understand it. Let me look at it again.
You done anything with Cassandra? I mean,
No, I haven't.
my understanding is that Cassandra and DynamoDB are at least related. Because I know they have similar developers.
Well, you can sort of.
Same developers.
So DynamoDB or Dynamo is a data store invented by Amazon.
Right.
They again wrote an academic paper on Dynamo and published it, but they didn't open source implementation, and they didn't let anyone outside of Amazon use it until last year when they launched DynamoDB, which is sort of similar to how Dynamo works internally at Amazon. So I did actually used to work for Amazon. I didn't work on AWS, but I kind of went to a bunch of technical talks, so I know a little bit about how their kind of internal systems work, like how S3 works, how EC2 works, EBS, DynamoDB, or Dynamo. I didn't know about DynamoDB until after I left. Sorry, what was your question? Did I answer it?
Actually, the Cassandra and DynamoDB are actually pretty.
Yeah. So the people who wrote Cassandra basically took the Dynamo paper that Amazon wrote and implemented it.
Okay.
And that's the open source version of
Kind of like
Dynamo.
what the Hadoop people did to Google's
Yep.
paper. Okay.
Yep.
Does anybody know of anybody offering like a cloud Cassandra as a service? I mean, I know you could
That's what
put
DynamoDB
it
is,
in
man.
your own EC2 besides Dynamo.
So Google has App Engine, and inside of App Engine, you can access the data store, which is it's actually written on top of a big table, which is sort of like a. I mean, it is different than Cassandra, but it's like basically a large scale NoSQL data store. But other than that, I don't know. Did you ask about a hosted version or?
Yeah, I was thinking of it as a service.
I mean, there are a bunch of companies that will run, a bunch of different open source projects as a service. So, like, you can get hosted MongoDB, hosted Redis, hosted probably HBase.
I think Ubuntu is doing one. I don't know if they're doing Cassandra.
Do you know what it's called?
Probably under Canonical.
I was just looking at it too. I can't remember.
NoSQL. I know I've seen something like this, but I can't remember what the.
No, it's reading Canonical not as the company, but as the.
Oh, what is it?
as
Do they have a hosted version of it?
I think so.
they're moving to some hosted services.
Yeah, they're doing some really interesting. They're coming up with a service that it'll manage your internal and your external cloud services, which is really, I don't think it does EC2. I think it does their hosting and your internal, which is kind of neat.
Yeah, I don't know what it's called.
I think it's Principally J. That's all I can remember. I could be wrong.
So I used to use MongoDB. So MongoDB is an open source NoSQL database. It's probably the most popular NoSQL database right now. It's pretty awesome, actually. And if DynamoDB didn't exist, I'd probably be still using Mongo for this type of thing. What was I going to say about it? Oh, there's like hosted MongoHQ or MongoDB services like the one I was using called Mongo Lab. It's like database hosting, so you can get some databases. And so in here they have like a sort of like a management interface. You can go and like look at your data. This is a previous company I worked on. One of the reasons we chose MongoLab is because they were hosted in Rackspace's data center, which was the same data center that we were in at the time. So you don't have to be in a different data center to access your database. It's probably a good thing. Lower latency. So MongoDB calls them collections. And you have like these JSON objects in your collections, and there's like references to different objects in your database. Kind of getting away from AWS, but this is sort of giving you the options. I mean, I think, and correct me if I'm wrong, Jamie, but I think you wanted this to be, mostly AWS, but maybe some other like big data stuff, or cloud.
Yeah, I can't see this making completely AWS.
Yeah.
We're gonna run out of things to talk about.
Yeah. So I'll just mention what else I'm using with AWS. So I'm actually using Heroku. Heroku was bought by Salesforce recently, like a year or two ago. And Heroku runs in the same region as the DynamoDB instance that I'm using. So it's kind of a low latency connection between my little web service and when I dump data into DynamoDB. Heroku is awesome, by the way. If you ever need like a hosted application, web environment thing, like I can't say enough good things about Heroku, except for it goes down sometimes. So if you're really worried about downtime and you'd lose money because of it, maybe you should do your own thing. But it's worked pretty well for us so far. So I'm using Python on Heroku. You can also use Ruby, which is what they started with, Java, a lot of other stuff.
What's app key written in? I mean, other than the neighbors, the website.
So I think we're using everything. So the Android stuff is obviously Java. The server kind of piece of it is Python on Heroku. Then I wrote these Hive queries, so that's Hive. And then MySQL, and then the website, the actual web user interface is PHP. So it's pulling from MySQL. So a little bit of everything. Java, Python, and PHP.
So to get back to DynamoDB for a second.
Sure.
When you're making basically design architecture decision, what's your thinking on whether you're deciding whether to put stuff in Dynamo versus build it in MySQL instances? Is it just the question of, can I run this in MySQL on a single instance?
So the way that I thought about this problem is DynamoDB is designed for high throughput applications. and lots of data. And the way that our system is structured is you have
Lots of read and write.
we have lots of read and writes on the device side. So we have a bunch of Android devices talking to us, and we have hundreds of thousands, millions of those. But on our website, when people go to our web page, it's only really developers and advertisers who are going to our web page. So we might have 10,000 of those instead of millions. And so that's a much lower kind of transaction rate, and there's less of them. And then I'm using MySQL because PHP has a really tight integration with MySQL.
Right.
So one thing here, I wasn't going to cover this, but since you asked, let me tell you a little bit about DynamoDB. So do I have anything in this table? Seriously? What is it doing? Oh, there we go. Okay. So DynamoDB is a key value store. Let me give a better example here. So it's a key value store. The key has two parts to it, a hash key and a range key. Let's see, how do I explain this? I think the hash key is primarily used for splitting up your data across machines. So this is the key, that is used to partition your data across machines. And then the range key is used for sorting your data within a given hash key. So the combination of these two keys is kind of your primary key. This is the thing that has to be unique. Each row is one. There's only one row with the same hash and range key. So you can do, there's a couple kinds of queries on DynamoDB, or a couple ways to get data out. Putting data in is pretty simple. You just write one row at a time.
So we're actually looking at the table.
Yeah, so this is the data in the table. So you'll notice that this particular table has a hash key, and so hash key is required, range key is optional. The hash key for this is request ID, and so this is actually just a randomly generated ID that I generate every request that comes in. And then I have a bunch of columns here. So you'll notice that in the previous page, only the request ID was listed. These other columns weren't listed. That's kind of on purpose. You can actually have, each row can have different columns. So like this next row could have an extra column that this row doesn't have. So it's kind of a flexible schema. You're not required to kind of have each row be the same. That can be useful, or it can just kind of blow up in your face.
Effect just shows up as a missing cell, right?
Yeah, it just kind of shows up as like empty or undefined or something like that. Okay, so there's let's see. So there's three ways to get data basically. One is a simple get or get. Now that I know, you basically type in the hash key or the combination of a hash key and a range key to get a single record. The second is a scan. The scan actually allows you to iterate through your entire data store. And I guess somehow these are ordered. I don't think it orders by the request ID, but there's some order, and then you get you'll kind of see, you get like the first 10, and then you press the next one, you get the next 10. This is the same way the API works. So you get like so many at a time, and then you can just cycle through them. And then there's also a query, which you can say, and query is only useful for tables that have a range key. That's why there's no query up here, I think. So let's find one that has a range key here. Does this have any data in it? Nope. That's lame. So if your table has a range key, so this is my hash key, this is my range key. The way I actually come up with my range key in this case, I'm actually just appending 2 fields here. So this is sort of how I got a key with more than 2 pieces to it. So I kind of put 2 in 1 here. So what you can do is you can say, you'll notice that these first 5 rows here have the same hash key but different range keys. So you can say, okay, I want, let's go over the query function. I want, hash key with this hash key, but I want, the range key to be between this and this, or greater than this, or whatever. And as long as this is set up so that you can only get stuff in a query that is stored together. So if it's logically like next together, you can get it. So there's different options here. So you can say equals, less than, greater than, between. And so between has two things here.
What happens when you click on that microscope or magnifying glass icon?
Oh, you just see the.
Oh, okay.
It's just a different format for a
Yes.
single entry. Then you can delete it from here if you want.
That way you can see all the fields.
Yep. I guess you can see all the fields here, but it's just a better view because this is like cut off, for example.
Well, you may have more fields than you've got in that table that would go across the screen.
Yeah, I don't know how it would deal with that if it had more fields. Yeah, so that's DynamoDB. I guess when you modify throughput, I'm not actually going to do it here, but when you modify throughput, you can change, how many writes per second or reads per second you want to do. And it takes a couple minutes to make this change because what it's doing is it's actually moving your data around so that it can handle that many writes or reads. You can only increase up to 2 times your current capacity. So here it says allowed values from 5 to 10. So 5 is the minimum period, and then 10 is just 2 times this number. And then you have to wait a couple minutes before you.
Oh, yeah, okay.
Because I think the reason it's 2, it's like, okay, like the first time it's like splitting your data in half and copying it, and then like, okay, it's splitting it again. You can imagine sort of what it's doing in the back end and why those limits are there. Oh, and then you can only decrease, like Jamie said, you can only decrease your capacity once per day. I think they don't want you to like kind of stop using instances overnight or something. I don't know.
Burst for an hour and then,
Yeah. It's like, because changing your throughput doesn't charge you for that, doing that.
But it's a lot of work for them.
But it's like work for them. So it's like, okay, well, we don't want you to do this every day. Just chill out. It's sort of the same reason why they don't let you, rent a server for less than an hour.
Right.
It's like there's a setup process, and they have to like move the data around, and they're not actually charging you for that. So it's like, okay, well, we're charging you 1 cent for just that setup process plus, the rest of your time.
Well, I don't want to keep people here forever, so I'm going to like blast through this, just kind of an overview. But before I do that, I kind of wanted to get some feedback from you guys. Like what are you looking for? Ideally, I'd like to do this once a month.